Hi, welcome back. In this video, we will start working practically some examples, basic mathematics with SageMath. So you will be able to run and learn something. So let's start here by writing a equal 2. So then I can call a, so it is 2. So it's kind of assigning here. And let's verify that a is less than 3. Yes, Sage confirming us a is not 4, so that's it as well. So gradually starting mathematics, exponential function. So it's E02, but I wanna see the exact number. So I'm writing numerical or n exponential of 2. So it will give me a number. Now I want to see that how can I control the precision here. So I can write in question marks or any function that I want to get help. I can write that function and question mark. The SageMath help will appear here, so we can see some examples and explanations. So I can control the number of the digits in this way. If it's not persuasive, so we can like Google that. So I can write numerical approximation SageMath and it will bring some bunch of pages. Okay, so we see here I just only need to write digits equal some number. Okay, I write here digits equal to 10. Maybe 10 is a lot. And I can change this in, I can write it in a capital version. Now let's make it a little bit harder. Yeah, I'm gonna define a variable x. So because I wanna take the derivative of sine x. Okay, sine okay, I don't know why I wrote for u. Okay, run it. So it worked. Now let's have a look at the main page of the SageMath closely a little bit. So here, this is the tutorial section. So here in the welcome to the Sage tutorial, you might see a bunch of information here. I'll click on 2 of them. So you see here the information which is in a very simple language. You will see that. So now here it's an example that we just did. So once you come here, you can surf by yourself here. You will see a lot of information which you have seen in Math2800 and Math1120. And I click on the ODE section. So in ODE section, maybe one of the main thing that we want to use is in this DE solve. So I'll give an example for this. And this is the Laplacian transformation which we have seen in Math2310 as well. Now let's go back to the work. Before solving an ODE, let's do one quadratic equation. Let's solve it. So as usual, I'm gonna define x as a variable. I write my quadratic equation in this way. So after writing it, just run it and you'll see the answer. So you don't need to use the quadratic formula for this. So Sage makes it easy to see the answers. Let's see another example. Having two variables there, so I wanna solve the equation in terms of the other variable. So I define two variables, x and y, and I'll try to solve a simple one. X times y equal 2. So I want to solve x in terms of y. So again, solve function in terms of x. Shift enter. Didn't work because I have to write -2 instead of equal to. So okay, you see that the answer is now fine. Now let's have an example in ODE. So before doing that, I can write question mark DE solve. It means that this function can solve first and second order in ODE. There's some explanations here, you can see that, and there are some examples that you can apply them. So I write, firstly I define my first independent variable here. So I'll define my function in differential equation in this way. A dependent variable which is depending on t, and I name the differential equation with this. So remember that we have seen DIFF already, and I wanna solve x prime plus x minus 1 equals 0. I wanna solve this function. So now I will write DE solve function. Just note that how I write these DE solve, so you see the solutions. We know that how to solve it from Math 1120, but now this time we see that the solution from the Sage. Now here I'm gonna work with two variables function. So I'll define x and y as variables. If I put comma between x and y, no problems, it will still work. So here I define my f to be equal x times sine x I'll try to get the differentiation of f in this way. I can take the differentiation in terms of y as well. I can take differentiation twice. Yeah, finally, this one. Instead of writing in the previous version, I can write in this way as well. Now let's go to solve a second order differential equation. So as usual, firstly I define my independent variable, then I'll define my dependent y variable in this way. Now I'm gonna define the differential equation that I wanna solve. So 2x means double dash y double dash plus 5 times y prime plus 6y. So that's a constant coefficient second order differential equation. We know that in order to be able to solve that, we solve the characteristic equation for that. So you see that we have, it is second order ODE, so we have two constant coefficients. Now let's have some plots. Okay, we'll start some simple plots here. So I write just a simple plot, and I'll plot the cos function here. In the interval that I want. Okay, this is the plot. Now let's plot this in the online SageMath. Why not? So I go to the website of SageCell, sagemath.org. Here, this is the way that we can do SageMath online. Okay, let's try some ODE here as well. Let's try some other simple code in online SageMath. So some differentiation, pasting here, then evaluate button. Okay, this is the solution. Derivative actually. Let's go back to the, okay, here. Let's continue plotting. This time I'm gonna plot a constant function. So I assign x equal to 5 and I wanna plot x to 3. So this function here. So let's try some little bit complicated. So maybe I can change the interval. So that works. Let's continue plotting and maybe complicated one. X cubed plus 2 times x in the interval maybe x minus 4 and 4. Okay, it is constant because in the above I assigned x equal to 5. To prevent that, we should have written, actually define x as variable. So it works now. We can change the plots here, the interval as well. I can actually remove x here, so it will work still. So this is the whole things that I wanted to talk in this episode. So I will make other videos. So hope you guys enjoyed. See you again.